Okay, for this problem we have a bivariate normal distribution. That's probably not realistic for weight, but that's another story. We have a bivariate normal distribution where we have this given values for the expected heights and weights, for the expected height and standard deviation for height, as well as expected weight and standard deviation for weight. We also have a positive correlation of height and weight, which makes sense. Tall people tend to be heavier than shorter people. Okay, so let's get going with this. To get started, let's write everything in terms of standard normal random variables. So that means the height will be equal to 70 plus 3 times z1, and the weight will be equal to 182 plus 35 times z2. Then I apply the standard trick that I showed in class, that I will replace this second normal random variable with this 0.45 z1, and that reflects the correlation between z1 and z2, plus the square root of 1 minus 0.45 times z3, where z3 is independent of z1. So z1 and z3 are both standard normal and independent. And the independent is going to save me when I start doing calculations. Okay, so doing the arithmetic, so this is 182 plus 15.75 times z1 plus about 31.256 times z3. Okay, so the question is, of the men who are 72 inches tall, about what percentage weigh more than 200 pounds? So I want the probability that the weight is more than 200 pounds, given that h is equal to 72. So let's turn everything into z's. So I want the probability that 182 plus 15.75 z1 plus 31.256 z3 is greater than 200, given that 70 plus 3z1 is equal to 72. Okay, so that means that's the probability that we have 182 plus 15.75 z1 plus 31.256 z3 is greater than 200, given that z1 is exactly equal to 2/3. So I can plug in 2/3 into here. The probability that if I plug in 2/3, I get 15.75 times 2/3 plus 182 is 192.5 plus 31.256 z3 is greater than 200. So that's the probability that a standard normal random variable is bigger than 0.23995. And then using the calculator, we find this to be about 40.5%. And so that's the probability that somebody that is 6 feet tall weighs more than 200 pounds. Part 2 of the problem asks about what proportion of men have weights in pounds that are more than 3 times larger than their heights in inches. I'm not sure how many people actually care about this, but let's go ahead and calculate it. So the probability that the weight in pounds is more than 3 times the height. Okay, now once again, I use my conversion factors that I see here. My height is 70 plus 3z1, and my weight is this line here. So 182 plus 15.75 z1 plus 31.256 z3 is greater than 3 times the height, which is 210 plus 9 z1. Okay, so rearranging things. So bringing the 9 over here, that's 6.75 z1 plus 31.256 z3 is greater than 210 minus 182, which is 28. Okay, now this right here, if I combine these things, that will also be a normal random variable. So let's let x be equal to to 6.75z1 plus 31.256z3. Then, by one of my rules, this x will be normal, and its mean is going to be 6.75 times 0 plus 31.256 times 0, so clearly that's 0. And the variance of x will be equal to 6.75 squared times 1 plus 31.256 squared times 1, and that works out to be 1,022.5. So this is the probability that this random variable x is bigger than 28, and if I convert x to standard units, that's going to be 28 minus 0 over the square root of 1,022.5. Doing the arithmetic, we get z is greater than 0.87564. And so using the calculator, we find the area under the bell curve, and that works out to be 0.19061. And so the chance that the weight is more than 3 times the height in their respective units is 19%.